Hello, good afternoon, everyone. I'd like to thank everyone for being here for this year's research highlight session at the Leman Conference. It's an honor to have everyone here to watch our 10 presentations that we're going to be having today. I'd like to extend a particular thank you note for Rachel Campbell that helped putting this session together, and also to Maria Peters, which I know she's around, I cannot see her right now, but she also helped putting this session together. And last, a thank for the 10 participants that kindly agreed to present their work over here. Sometimes it takes a lot, so I appreciate everyone that is going to be presenting here today. That said, I'd like to invite our first presenter, Mariah Musskopf from the Iowa State University. Please come on in.
Thank you, Dr. Popowski, for your kind introduction, and thank you for the committee for selecting my work for this session. I'm very happy to be here. So today I'll be presenting my project that is entitled Assessing the Probability of Detection of Salmonella Between Oral Fluids and Fecal Sample Methods Under Commercial Conditions. And I would like to start thanking BI for sponsoring this project. Okay, moving forward, Salmonella is a pathogen that is found worldwide, and it affects most of herds everywhere. This pathogen not only causes health issues and performance issues, but it's also a food safety concern. And the traditional way to detect Salmonella for pigs is through bacteriological culture methods, and it's usually using fecal samples. And then we have oral fluids, which is a preferred population-based sample that is used for detecting several infectious agents for pigs and offers a very practical, non-invasive, aggregated collection method and can enhance herd levels sensitivity compared to fecal samples. And then that led us to our research question and our objectives that were investigate the use of PCR for Salmonella detection in oral fluids and pool. Do we have, oh, sorry. And pool pen fecal samples, assess the agreement between those sample types, and also assess the probability of detection using oral fluids as an alternative to fecal pool sampling in finisher sites under field conditions. And then how we do that? We started having our eligibility criteria that we looked for flows that had a history of salmonellosis, and we wanted to find facilities that were as similar as possible and in finisher sites, so the pigs would have in between 10 to 11 weeks, and they couldn't have received the BI Lawsonia vaccine. And then when we selected a bunch of farms, we had over 10 farms that we went sampling for the pre-screening. We perform only fecal sampling for that. We sampled 6 pens per farm, where we collected using a Whirlpack sterile spoon, 25 grams of feces from 5 different points of the pen floor. And then we submitted it for the ISU VDL, where we was double enriched using Rappaport and tetrationate broth, and submitted for PCR. And when we had at least one positive, we selected those farms for further sampling. So for us to define our sample size, we used a McNemar test that led us to the number of 51 paired samples, or 51 pens, that we sampled through 3 different sites. So we had 17 pens per site, a total of 102 samples from facilities that had around 22 pigs per pen and that were 11 weeks old. And then in that sampling, we performed the same fecal sampling that I explained, where we collected from 5 different points fresh fecal samples. And also we tied up cotton ropes for the oral fluid collection during 30 minutes. And our goal was to get at least 10 mL of oral fluids. So when we got those samples, we brought everything up to the ISU VDL, where the first thing that happened is that we took an aliquot for PCR, so that sample was raw, no enrichment. And the rest of the sample, we use the LOV method, which uses 2 enrichment broths. And then it was cultured, and using the Malditov technique, those bacteria were identified. So for the statistical analysis of those results, we performed percent agreement to find the concordance of results, McNemar and Kappa for agreement between sample types, and also a logistic regression model to estimate the probability of detection. So moving forward to our results, this is the descriptive results that we found. So for those samples that have not received enrichment and were to run the PCR, we found 0 positives, which was kind of surprising for us. And then for the culture, we found a way bigger number of positives, where we found for our first site, 14 out of 17 for both sample types. For the second site, we had 100% of samples being positive for feces, and again, 14 out of 17 for feces, for oral fluids. And our third site, we had a slightly lower number of positives, where we had 7 out of 17 for feces and 4 out of 17 for oral fluids. And then what we do was to perform the agreement test. And based on a 2x2 table, we found a 72% agreement between those samples. However, both McNemar came out negative, and our Kappa agreement only showed a fair agreement, which was not very expected looking when we found that we have a big number of matches, right? But that can be explained because we had one category that was dominant over the other, so we had more positives being a match, and we had less than 25 discordant pairs. And then, for our probability of detection, we found really good results, where we had 81% of probability of detection for feces and 66% for oral fluids. However, those numbers, even though they appear to be different, they have no statistical difference, meaning you can use either sample type and you will have the same probability. And then a little sneak peek in our next steps. So we used the enrichment broth that later was cultured to run a PCR on. And what we found is that when we used enrichment, we had positives. And this, not only we have positives, but they are very similar to the culture. This is just a sneak peek because I haven't run the analysis for agreement yet, but those are the next steps. And then the take-homes of this presentation is Salmonella, yes, can be cultured using oral fluids, and it is a novel practical option for field surveillance of Salmonella. We found high detection probabilities for both sample types without statistical difference between them. And if you want to run PCR, make sure that you request them to be enriched. I would like to thank my advisor. Unfortunately, he's not here today. And thank again Boehringer for not only sponsoring this, but Dr. Fernando Leite for sharing his expertise since the moment that we defined the research question. The doctors Macedo and Golger from the VDL and the girls from the lab, my coworkers and friends that help. There is no work that is done alone. And of course, the participating system that helped us with the sites. And with that, I'm open for questions. Thank you.
Maria, perhaps just a clarification question on the methods. When you did the PCR, was it from the enriched samples, or you put in the slide enriched PCR? Or did you mean that you ran the PCR after they had been enriched in culture?
We had both. So first we ran the PCR in the raw sample, so without enrichment. And then we have saved the enrichment broth after the second enrichment before put it into plates, and then we submit it for PCR again. So that's how we did it.
So why do you why do you think in the oral fluids that you didn't pick it up with the raw PCR? It seems, is that just the level of detection when you go to the enrichment, or why do you think there's that difference?
So first of all, there's no difference between any of the sample types. The PCR didn't detect any positives for any of them without enrichment. And the problem is not the PCR. The PCR is validated. The thing is that Salmonella requires a little bit of a boost to be found there, because without the enrichment, it can be overpowered by other bacteria, or even there are some types of inhibitors in those sample types, both feces and saliva and environmental things that can be in the oral fluids.
To continue on that point, would that mean that if it would have been a clinical case of Salmonella, then you would have maybe a higher yield of Salmonella in infected pigs, that those would have functioned without enrichment?
I would say yes. I think that's possible, because that's what happened when we do the enrichment, right? We make those bacteria grow, so you have a bigger amount.
Just curious, on your pooled fecal samples, approximately how many were you collecting per pen, and how large was that sample size on the pool?
So we were reaching 25 grams of pooled fecal samples, and we use that Whirlpack spoon that has the 15 ml capacity, and we did some pilots to see how much it would be with how many spoons. So we noticed that if we had like 5 different points, one like shallow spoon, we would have over 25 grams. So basically that.
Well, thank you so much, Maria. I appreciate your presentation.
Thank you so much.
I would like to invite Angel Martinez to come present here. Angel is coming from South Dakota State University. We'll just get him set up so he can begin his presentation.
Okay, nice. So my presentation, it's about effect of high soybean meal inclusion on gut microbiome in finishing pigs. Thank you so much for the introduction. I have met Dr. Igor a couple of years, and it's a pleasure to be here back again in the University of Minnesota in the Leman. First, a little bit of background. The industry have found like more net energy in soybean meal compared with, for example, the NRC values. And Dr. Eric Weber has been in his lab, has been doing a lot of research about getting to trial that to able to test this. And he found that, for example, compared with DDGs, he found up to 4% heavier pigs, which is something that with lower prices expected in soybean meal, it will be a reason to do more research needed to take advantage of this commodity. So he came to my farm. I'm the assistant manager of the off-site swine unit at SDSU, just South Brookings. And he came with corny pollen to make research when they had 2 treatments for the pigs. First one, low soybean meal diet, which consists in a lot of DDGs, more synthetic amino acid to compensate the great profile of amino acid of DDGs, and then the high soybean meal, which was more soybean meal, no DDGs, and less synthetic amino acids. The crude fiber was around the same. So the performance data, we saw that at the beginning of the day 56, we're starting to see those nice differences that we were expected, but it was actually higher. We were at a certain point 11 pounds higher in average within the 2 groups, and that went until the end of the trial. And as a person who wants to specialize in microbiome in animal sciences, for me was something that I needed to like check with this. And then could the microbiome would be involved in this? So this is the analysis basic workflow that we have in our lab, in the microbiome lab. We collect feces of sample collections. Then we did the DNA extraction, the PCR, sequencing, and bioinformatics. Just a couple of definitions. The 16S rRNA, it's an analysis that will tell us within the samples which species are present and how abundant they are. An OTU is just going to be a denomination for the 16S rRNA gene to identify bacterial species. So right away, we run the data into PCOA. That this visualization will allow us to make those nice differences in the matrix of like Bay-Curtis distances. And we see that the data, it's getting through, like the soybean meal is the red one and the other one is the blue. And then we also did a Permanova analysis with the vegan R package, and we run it at 999 permutations. We found significant difference as expected. And these are the main bacterial species by proportion. That's the average of between the samples. And these are the marked in red. Those are the Crystal Wallis analysis. The difference that we found, the OTUs that we found difference between treatments. So this is the matching OTUs to known species by BLAST. The code that we use for consider one species that was previously described was the 90%. As you can see, like most of them are unknown species. But yeah, there are a couple of ones that they were previously described. Obviously, Streptococcus is there, Lactobacillus is there. And this is a differential abundance that we did with logarithm. And you can see in there that, interestingly, the one that made the highest jump was the Treponema brillanti. It's at the top of the graph. Then one species called Aenerotroncus, and then also another genus Treponema was found in there, which was very interesting for us to find those bacteria who grow. So we know who is there. So now, what do they do? So just a little bit of background with the microbiome. We, in a soybean meal environment, we think that those oligosaccharides that the animal cannot digest get into the ingot, and then the animal cannot digest it, but actually, so there's some bacteria that might be able to get through those plant fibers. Those bacteria are able to produce other subproducts like short-chain fatty acids, and then some bacteria are able to use it. Then that bacteria, it's able to exchange that back in vitamins, hydrogen, or amino acid. That's what we call in the business of microbiome cross-feeding. And then the cross-feeding is not only beneficial for the bacteria themselves, but also for the host, because the epithelial cells are able to use that energy to generate ATP. So today we are going to focus in those nice chyenzymes for getting those fibers gone, and then short-chain fatty genes. So we were able to retrieve 26 MAGs or metagenomic assembling genomes, and please do focus in the fact that these are, again, our lactobacillus. Then we have an Streptococcus, and there are treponemas, that change because of the 16S analysis, and we're able to see that they're also able to generate lactate. All of them were able to generate lactate, but the difference between this group and these two are that we have like that breakdown of carbohydrates, which was very interesting to see that, the differences. So we have our lactic producers, which was those genus. We have that the system in particular is able to break down those saccharides. And then now let's look at the let's look at the butyrate. This butyrate, the short fatty acids, these are the ones that are going to be able to be used by the host. So one of the interesting things that we found was that treponemas might be benefit from amino acid, that amino acid environment that we think that soybean meal could get through. And just to comparing the top 20 pathways of gene counts, treponema versus bacillus, we can see that the ones who are higher in the treponema are the amino acid utilization, breakdown, and amino acid transport. That's the way that they can grab that from the environment. So, but they are able to take it, and more, actually more species were able to take it. But what I want to point out is that there was little evidence of fermentation of amino acids. We think that most of the amino acids that the bacteria are able to take from the environment are basically for building blocks. One of the observations that we saw in here is that in the high soybean meal environment is that lustules, which in the experience of the person who is managing the animal, seeing the animals every day, we saw also that it causes less prolapses, but that's something that we just observe, and it's just an observational thing. In conclusion, microbiome profiles change high in the first treatment and the second treatment. In high soybean meal, we know that the treponema, Aenerotroncus, and Guopinga are the species that change the most. And in high soybean meal environments, we found evidence of several species that can metabolize oligosaccharides. That evidence that short fatty acid producers are in the environment and might be beneficial to the host. I need to point out that we didn't do any measure of butyrates in this in particular, in this trial in particular. And then we have evidence of amino acid uptake, and the rabbit hole that we want to get into it now, it's like the synthetic amino acids versus soybean meal. That would be nice to see. What are the differences in microbiome? Because we found they're prone to have less prolapses. So our going research, the microbiome lab is going to try to look association between sulfates and lipids in DDGs. We're going to do a transcriptome analysis to see which genes are expressed in high soybean meal. And the Weir group is looking for the possibility of IGF circulation and doing that research that I was telling you about, testing fiber mean the soybean meal versus a diet that just compound of just synthetic amino acids. For me, I would like to publicly appreciate that Dr. Weber want me to collaborate with me and our lab. Dr. Benoit Saint-Pierre it's my advisor in SD State, and those nice people that you see in your screen. Thank you so much.
Thank you so much for your presentation, Angel. Are there any questions for Angel?
Right here. Did you control the fiber content of the both diets?
Yeah. It was actually, they were trying to get roughly the same, and the way that they do it in the low soybean meal was to, instead of using soybean meal, it was more DDGs. And they were roughly the same. I think I have some, excuse me. I think, let me see if we can get that quickly here. Well, anyways, yeah, there is more people presenting that, but yeah, it was roughly the same. The fiber crude fiber was roughly the same. Oh, okay. Let me see if I can find it. The diets in here. I don't know if I get it there though. Now that I remember. Oh yeah, there you go. Yeah, the crude fiber was roughly the same in the phases. Those are, I take just this in consideration just because that's where I took my microbiome samples.
Any additional questions? If not, then please help me thank you, Dr. Angel.
All right, so next we are going to have Dr. Valeriia Yustyniuk. So Valeriia from the Center for Animal Health and Food Safety at the University of Minnesota. So I get to work closely with Valeriia, and she's going to tell us a little bit more about some of the language learning models that they've been working with.
Yep, perfect. So thank you for introduction, and thank you for this opportunity to present on behalf of our team. Today I'm going to share our experience. Yep, sorry about that. So today I'm going to share our experience. No. Do it again. Like this? Awesome, perfect, finally. So today I'm going to share our experience on exploration of large language models in tackling certain diseases, not diseases, but processes we used in our bigger project. And first of all, I would like to acknowledge my colleague, Dr. Jasper, who is sitting just in front, who is an integral collaborator on this project and a driving force. So if you have any questions, you can address them to me or Jasper. So at the beginning, I will share some background on how we came up with the idea of exploration these tools, and I will walk you through the methodology we used and our results, and we will discuss some limitations and challenges, as well as future steps. So our team at CAFS monitors swine transboundary diseases across the globe, and we provide this monthly reports since 2017. In our work, we use different sources of information, starting with official reports by WAHIS, WA, and FAO, but we also use some local news. And at some point of time, we just realized that the access to information is no longer a problem. However, the quantity of that information and the quality of the information is. So this is how we came up with the idea of using some of the AI tools to help us process the information. At this point, I'm not going to provide you one-on-one large language model course. However, I would like to stress several key concepts, how they work, in order for us to understand the logic behind it. So large language model is an AI tool which is generative in nature, meaning that it creates new text in the form of a summary or a paragraph. It doesn't only extract facts, it also creates them. It is predictive in nature, so it recognizes certain patterns and uses them in predicting the next word or phrase. And it is knowledge-based, so it does not create the new content, it uses only information which was used to train the model. And this brings us to our objective of our project, which was explore the use of large language models to enhance the efficiency of information processing. And we were basically focusing on extraction and summarization. For methodology, we used the same process we use in our everyday surveillance project. So we set up Google Alert. The only difference was we focused in this project only on African and classical swine fever. And we received daily emails showing us the news around the globe about this disease. Then we filtered that news manually because some of them were not relevant. We were focusing only on those which were presenting some outbreak information. And then we used a script just to extract this information to our database, so then we can use it for our models. We started with about 200 news in our mailbox, but then once we filter it, we ended up with 26. Once we had our extracted information, we fed it to 4 different models, and by using standardized prompt, we received some output, which we actually reviewed and evaluated. For the prompt, as I mentioned, it was standardized, meaning that each model received the same prompt. And we asked the model to step up in the role of experienced swine health medical data analyst. And we asked it specifically to extract 7 key elements: disease, species of animal, location, number of cases, number of deaths or animal slaughtered or culled, and date of report release, and the initial date of the outbreak, and source of the report. And we also asked to provide a short summary up to 100 words of the key facts identified in the paper or in the news. For methodology, nowadays there are several metrics already existing which actually evaluate the performance of large language models. However, those metrics measures very specific parameters. For example, how fast does the model provide the output, or how the language used in the output differ from the language in the input. We were interested in slightly different things, so for the extraction part, we adapted those existing metrics for our purposes, and we focused on 2 main criteria. Recall, did the model actually fill out all the fields we asked it to fill, and how precision score, how accurately did the model do that. For summary evaluation, we used mostly qualitative approach, and we used Likert scale from 1 to 3 to assess how correct or accurate facts were extracted and how clear the summary was presented. Here you can see the results. All models did pretty good job in extracting information, so none of the fields were left blank. However, for precision score, we can see some variety of results, and this slide we can see that DeepSeek showed the better results. However, we have to be cautious in this situation, because even if the model extracts information 100% accurately in 9 out of 10 cases, the one case which it messes information up makes a great difference, and we won't be able to know that unless we actually review the initial information. So this is a great deal. When we created a prompt, we set up specific constraints, and we asked the model specifically to state that information is not available in the initial source if it was not there, right? So we can see that for some very easy parameters like disease and species or location, all models did pretty good job. But then if we look at the source provided, which was not mentioned in our initial input to the models in many cases, some models tried to assume things and maybe even go and search in the internet, which we didn't ask specifically for. For qualitative results, for correctness, we can see that DeepSeek also did pretty good job, but for clarity or coherence, ChatGPT for O-Mini was obviously better. What challenges we saw with the performance of these models? Hallucination of facts. We already know this. The models do that. They add details which are not present in the original article. That's our finding. But I think that many of us in the room also experienced this in exploring these tools. Also, ambiguity in summaries, meaning that some summaries provided in output were lacking clarity or precision, causing confusion for readers. And overgeneralization, meaning that models produced over general or over vague, broad statements instead of specific facts. And this graph is basically showing what is already identified or described in the literature, and our findings pretty much align with what is there. What we've learned, opaque algorithms, meaning that we don't really know how the model performs, and probably we will never know this. So this is something to consider when we use these instruments. What we noticed is that the length of the prompt and input actually matters. If we have the shorter prompt, more concise prompt, and we have shorter news, the model performs better and it provides more accurate outcome. For information blending, sometimes models pick the facts from the paper or from the news and put them together in not logical way, and this actually messes things up. And limited domain knowledge, this is where we as experts come in, because we can, as veterinarians, we can make sense of combining or having together animals, farms, and environment, which models don't know, they don't make sense of that, and they don't extract the facts we are interested in. For limitations, at this point, we used only 4 models, and unfortunately, they were not, we understand that everything is changing and everything is developing, and tomorrow we will have version 10 or version 12, you know. But this project is more over exploration exploratory nature. So using our criteria and our logic, we can next assess whatever model appears and see how accurate is that. Generalizability, as I mentioned, we focused only on 2 diseases, African and classical swine fever. If we expand it to other diseases, we don't know what results we will receive. For evaluation metric, as I mentioned, we adapted it from whatever is on the market. So it is a little bit subjective. And in this project, limited computational resources was not a big deal. However, if we want to scale up our project, it may be resource, we will need those resources. To conclude, I would like to mention that LLMs actually have the potential to speed up information processing, but we still need that expert supervision to control the outcomes. And deploying the model can improve both accuracy and efficiency, but results remain somewhat unpredictable. In the future, we are going to evaluate the model's capability to identify and prioritize relevant news, basically what we are doing manually right now. And we are going to explore other transformer models such as BERT. I would like to acknowledge our team members and the funding agency, SHIC, for providing some funds for us to be able to do this. And thank you very much for your attention. Any questions?
Thank you. These models, they can be trained over time, and they can have different outputs over time. Do you believe with a lot of time with each model, you can have different outcomes that you have in this work?
Thank you for your question, and that's a great question. Yes, we started with untrained models just to see in general what they do and what are our limitations. And we also think about training it, because training a model requires resources. So the question is, if we train a model and if we put these additional resources, what the outcome would be? Will we face the same challenges? And if at the end we still need a person looking into initial source just to make sure that information, the output is correct, then is it, like, do we need to put the resources in the training or not?
Thank you.
We have time for one more question.
I thought it was really interesting. So one thing that I understood from your presentation is that even though, the performance was 85%, right, you still have to go manually and look for the data, right? So in practice, how is this improving your monitoring right now, or do you think, is it applicable right now? The way, the way that those models are set up right now, are they useful already, or do we still have more development to do on that sense?
Great question, thank you for that. So at this point, we see some potential for use of these models, and it depends on the task you want this model to perform. For example, these models are excellent to cut your final project to a certain amount of words, right? But you still need to read what the outcome is and what was the input. So you cannot just put the whole bunch of papers saying, hey, please analyze this for me and provide all of the summaries. In this case, you don't know which one is accurate and which one is not. And once again, it depends on the nature of your work and what are you going to do with this result. In our case, we are providing this monthly report, which is read by a lot of people, and we want to, our information be correct and as accurate as possible. So at this point of time, we cannot rely on those models, but maybe next steps and maybe next developments will make the situation better, improve.
Thank you so much, Valeriia. I appreciate your presentation. And with that, I would like to now invite Magdiel Lopez-Soriano from the University of Missouri to present here.
Can everybody hear me? Okay. So thank you. Thank you to the Leman Conference Committee for letting me speak here. I'm going to present this cool project that I had in the last 1.5 years, identifying the experience, skills, and professional background of TN visa workers in the U.S. swine industry. So I work for the University of Missouri and the Extension Department. So as we know, for many of us that we've been working in the swine industry, when the North American Free Trade Agreement was signed in 1992, opened up the opportunity for Canadians and Mexicans to come and work legally here in the U.S. And then a little bit of history is that in 2023, around 34,000 TN visas were approved, mainly, of course, from Mexican professionals. However, in the 2024, that number decreased in about 53%. So we know that the TN visa workers in the U.S. have been extremely important in supporting our swine systems across the U.S. What we know is all of them, they hold a bachelor's degree in order to get the visa approved. However, when we compare to regular Mexican workers that come and work in agriculture, this is, goes beyond the high standard where we compare those Mexican laborers, they only have 22% of some college or have reached some college, and that's another important highlight for these TN visa workers. However, they face communication barriers. They prefer to speak Spanish in our experience. However, at this point, there was no data regarding to that. So what we did is we designed a survey and with two objectives. The first one is to capture their cultural and professional background, their skills and experience, and for future opportunities within the swine systems. And also to determine themes of satisfaction factors that could drive to look for another opportunities, and also to investigate the incentives that will increase morale and retention. For time constraints, I will show only data from the first objective. If you have more interested in knowing this, I will have a poster downstairs around starting at 5:30. So what we did is we developed a survey, and what we did, we deployed the survey in 7 states. We did the contacts, and we did around 211 employees in person. And in other 9 states, we captured around 50 responses through an online tool. We developed a 35-question survey, and we collected the following themes: general farm information, demographic, cultural, professional, and academic backgrounds, personal and professional goals, training opportunities, work conditions, and also factors driving satisfaction. The results is, so you can see here the survey, the breakdown. Mainly we had the opportunity to do more in North Carolina, Missouri, Ohio, Iowa, and Illinois. But also you can see here the breakdown on female and male ratio, and we will see that later also. So here is interesting that the U.S. swine industry is able to attract younger people between 26 and 34 years old. That is, 60% of them. We found that that was interesting. We found that also that 60% of them, 64% of them were males. And also we asked them, how long have you been on a TN visa program? Found out that around 52%, 53% are between 3 and 6 years. We asked them also, where you coming from? What is the area where you grew up? And roughly we can say that most of them grew up, in cities or urban areas, and the other half grew up in small or rural areas. Results in experience, 2/3 of them, they come with some previous experience, and the main experience are related to crops, dairy, cattle, beef cattle, sheep, and goats, and poultry. What is your current position? And the highest education level as well. Interesting enough, we found that 10% of them hold a master's degree, and also we found one that even holds a doctorate degree. The main degree earned in Mexico were agronomist and veterinary medicine as well. Animal science is another one. So they bring a lot of good background experience for our systems. We asked them also, what is your current position in your farm? And mainly around 75% of them were hourly employees, and most of them were in the farrowing department. This might be biased because the contact we have, they were more on the sow farms. So we also asked them to self-assess their English literacy, and also we got that the response of them is like 80% of them, they're still more comfortable speaking in Spanish. We asked them also, what do you feel when you have to speak English? It is basic, intermediate, or advanced, and 65% of them, they consider themselves to have only a basic level of English. We asked them also, why do you come to the US and work under a TN visa work permit? And you can see here the themes that we collected, but also you can see the percentage on the x-axis, and you can see how much they rated the importance. Very important, important, highly important, and so on and so forth. So in this case, the main reason is because they want to get a better salary compared to what they get in Mexico. And that they highlighted that is, about 78% of them, they say that is very important for me. Are you interested in promotion and interesting? 76% they responded yes. That's also, to me, was a shocking finding. We asked them also on your professional goal, why would you like to get soon in your career? And of course, most of them, they mentioned that a salary increase, but also they're still tied up with the previous finding that they like to get, or at least to apply for a promotion. Conclusions, we know that the NAFTA visa workers are highly educated and bring a lot of wealthy experience. TN professionals show some promotion interest in career advancement and will possibly apply for a promotion. In terms of professional goals, of course, they have financial objectives. And in our opinion, the group that we've been working on this, there might be some strategies that we can use to better manage this population. One of them is maybe design a customized training for these employees in English and Spanish to motivate them and develop their skills. And maybe some create some temporary position like a biosecurity captain, onboarding training leader, animal care supervisor, of course, they will have to bring some incentive. With that, I'd just like to acknowledge the swine producer and all the team that have helped us to get this through, and the National Pork Board for its sponsorship. If you don't have any questions or you want more information, you can.
Thank you so much for your presentation, Magdiel. Are there any questions for Magdiel Soriano? Well, I do have a question. So, Magdiel, how easy is it to get to access and to obtain information from the population of workers on these farms, particularly those coming under the TN visa?
It is challenging sometimes to go through the company. And I understand that when you contact the HR managers or the production managers, they normally say yes, but it's one more thing to do. It's like they're busy with their lives or professional lives. But what we had to do here is like we know the team knows a lot of TNs, so we asked the University of Missouri IRB office to get approval and contact directly and hand out the survey, and that was the only way that we could get in some cases some information.
You mentioned the reduction year over year on number of TN visas coming into the U.S. Is there any data as far as the number of applicants trying to obtain these TN visas? Is there a reduction there? It's strictly related with the ability to obtain those visas.
Yeah, that is a good question because that happens last year. But according to, for example, the National Pork Board, the National Pork Producer Council, I made some phone calls about the reason why this was being denied, and there was no answer. I mean, they didn't have any answer. What we know now is that some producer association, like the Illinois Pork Producer Association, brought a few U.S. embassy consulates and showed them what they were doing and that the program was beneficial for both parties, and that seems to help with the approval rate.
So next we have Dr. Laura Solis. She'll be talking to us about sudden death in sows.
Good afternoon, everyone. Thank you for the introduction. Today I'm excited to share some findings from our necropsy project. So this presentation has the title of Sudden Deaths in Sows, Patterns Across Parity and Production Stages. So here is our outline for today, including the importance of sudden deaths, study goals and approach, some key findings, and finally, take-homes. This is our first graph that is showing us that most of the sows don't break even until they have had at least 3 or 4 parities. That means that we don't recover the cost of developing and breeding and gilt until she's had a few productive parities. In the US, the average culling parity is around 3.5 to 4. So that means that more sows are removed or died just as they start becoming profitable. Now in this chart from Meta Farms is showing us that 34% of the sow removal is classified as unknown or other. So that's why the goal from our project was to identify patterns in sow mortality by using systematic necropsy protocols and data collected on farm. We aim to understand why these animals were dying and when during the production data, and linking those findings with production data. So this necropsy project is part of the Improving Pig Survivability project, but this one is focused specifically in sudden deaths in sows. So we performed 145 necropsies from 2 commercial sow farms in the Midwest US from September 2024 to June 2025. From each case, we collect data such as production stage, body condition, parity, stillborn history, gestation length, and growth findings. So here's our first plot that is breaking down the overall death causes from the 145 cases. And here we can see that retained piglets is the main cause with 28%, followed by gastric disorders such as acute ulcer, perforated stomach ulcers with 19%, and cardiovascular failure 10%. Now in this plot is showing us sow mortality by parity, and here gilts, P1s, and P2 accounting together for 50% of all cases. Now in this plot is showing us the death causes by parity, and we can see that gilts and P1s, the main cause was gastric disorders, and in P2s, shift to retained piglets, and in older sows, besides the retained piglets, also there were splenic and intestinal disorders. Here we are looking how we distributed the cases by production stage. So in case of breeding, there are included queen sows, open gilts, opportunity, and culls. Gestation is from day 1 to 109 days of gestation. Pre-farrow 110 to 115, and farrow is at the moment that the sow farrow and the entire lactation period. We can see that farrow has 55% of the cases, gestation 29%, pre-farrow 9%, and breeding almost 7%. So combining the pre-farrow and farrow stages define the peripartum period, that is the time just before, during, and after farrowing, and this is the most critical time for the survival of the sows. Now in this graph is showing us a weekly view of sow mortality across the 20-week sow production cycle, highlighting the gestation and peripartum period. And we can see that during gestation we have a low mortality, though there are some peaks. I will address those in the next slides. And continued gestation, and after the animals enter into the peripartum period, we start notice a sharp increase in sow mortality on week 17. That is, corresponds 119 days, just after farrowing. Going deeper into the peripartum period with 93 cases, here is our plot breaking down the overall death causes, and we can see that retained piglet was the main cause with 40%, gastric disorders 21%, and intestinal disorders such as torsions and ischemia 11%. Now here in this plot is showing us when the animals died during the peripartum period, and we can see that the sow mortality concentrated right around farrowing during the first 7 days postpartum, and a clear peak on day 120. So next plot here is the death causes day by day during the peripartum period, and as expected, retained piglet was the main cause, but also we can see that intestinal and splenic disorders just appear after farrowing. Focuses on retained piglets. We have this plot that is showing us the distribution by gestation length, parity, and the number of piglets that remains on the uterus. We were able to assess 17 cases out of the 37 total retained piglets cases. That represents 46% of all retained piglets cases. And we found that on average, 5 piglets remains on the uterus. So it's important knowing the herd's average gestation length for induction protocols. Inducing more than 2 days early can harm piglets' maturity and survival and can increase the risk of retained piglets. So here in this plot is showing the dots are the cases, and here depending the parity of the cases. For example, we have this sow that is parity 4-5. She had 17 piglets in the uterus. Moving on to the gestation stage with 42 cases, this is our plot that breaking down the overall death causes, and here is our top 3. Splenic disorders with 21%, cardiovascular failure, and gastric disorders, each accounting for 17%. Next plot is showing us when the animals died during pregnancy, and 26% were in early gestation, 29% in mid-gestation, and the highest mortality was on late gestation with 38%. Interestingly, the most stable time was between 30 and 50 days of gestation. Here in this plot is showing us the death causes across gestation broken down by 10-day periods. And we can see that splenic disorders, but also gastric disorders were common. But here we can also see some retained piglets cases at late gestation. So here these cases were from sows that aborted a couple days before they die, and we found in the necropsy retained piglets. Next, production stage is breeding with 10 cases. And here the death cause is quite varied. Some of them were reproductive disorders such as pyometra, chronic infections such as polycerositis, and retained piglets. So here the cases were post-farrow and opportunity sows, so timely treatment and proactive calling can help us to prevent deaths. So here's a good example. So from a pyometra, so this case was from a gilt that was presumed pregnant, and she was treated by Leman a couple days before she died. And on the necropsy, we found this distended uterus with thick walls and also purulent exudate content in the horns and in the cervix. Talking about stomach ulcers, so out of the 145 cases, 81% of the cases had any grade stomach ulcer, and the most common was grade 2. So here in this slide, it's showing us the different grades of stomach ulcers in the partisophagia. So on the left, we have a normal stomach that is white and a smooth surface. Next, on grade 1, there is parakeratosis that is rough and thick surface. On a grade 2, there are erosions. On a grade 3, the ulcer is present with or without stenosis in the partisophagia, as we can see here. Just to wrap up our take-homes, so first we have that the peripartum period is the most critical time. 64% of the deaths occur during this period, and especially during the first 7 days postpartum. Secondly, retained piglets. Retained piglet was the main cause, and also inducing more than 2 days early can affect piglets' maturity and can increase the risk of retained piglets. Third, parity trends. So 50% of the deaths were gilts, P1 and P2. And also gastric disorders, it was more present in young animals, and in older animals, besides the retained piglets, also splenic and intestinal disorders. Next, sow mortality in gestation is not random. So 29% of the cases were in this period, and the highest risk is in late gestation and could be related with stress events. And finally, stomach ulcers. So 81% of the cases had any grade stomach ulcers, so it's important to evaluate feeding management to reduce feed disruption and stress on the animals for the prevention of ulcers. And this work wouldn't have been possible without the support from my mentors, Dr. Almeida, Dr. Chris Rademacher, my colleagues, Iowa Select Farm, BDL, Field Services team. Thank you very much. And thank you all for your attention. Happy to take any questions.
Thank you, Laura. Any questions for Laura?
So I think it was maybe because you didn't span the summer, but you didn't see any seasonality for mortality?
Yes, that's a great question. And yes, well, this data is until June, and we are continue doing necropsies in our next presentation that it will be in Nebraska. We are going to talk about more about all the necropsies from July, August, and September. And yes, seasonality, we can see. Yeah, thank you.
A great presentation, Laura. Do you know if this farm where you collected data from had used any induction protocol for synchronizing farrowings?
Sure, thank you. Yes, they have their protocols of induction, so they were inducing at 115 days. So, yes.
Were these just in one farm or multiple farms?
So, no, yeah, well, and this data is from two sow farms.
Was there any difference in the farms and staffing in the farms?
Yeah, sure. Yes, absolutely. That is another, each farm, it has their characteristics on management. Even if they have the same protocols, of course, we can notice some differences.
Nice job. You guys have done a lot of nice work there. Question for you, what should the target, sow mortality target be in the United States? What percentage?
I think so. That is the big question, and everybody can wanted to say something. One of the targets, or maybe most of the farms are mentioning that less than 12, 10% of mortality. Yeah, listen there. Sorry, Mari.
I was just wondering if that percentage, that goal changes accordingly to the ASV classification for PRRS.
Yeah, exactly. Yes. You're right. It depends of how is the status of that farm, the health status. Yes. In this case, these two farms were stable of PRRS. So, of course, in all the necropsies, we didn't see like the characteristic cases from PRRS. Yeah. Thank you.
Well, thank you so much, Laura. Thank you so much, everyone, for the questions. Again,